Great. I'm going to kick us off here. So I'm going to go through a few slides here on kind of whether or not data mesh might be right for your organization. And then Barr's going to take over and talk through how our customers and a lot of the companies that we're working with are starting to measure like the ROI of data mesh to actually prove out that it was a worthwhile decision and that it's providing value over time. And then the main event here is going to be our good friend Antonio, who's going to talk through Kolibri Games' data mesh journey. It's a really interesting one, and we're lucky at Monte Carlo to be a small part of it. We started working with Antonio last fall and got him up and running on the platform, but I'll let him tell that story when he gets there. Yeah, so Molly, next slide. To start with the big question, to mesh or not to mesh, that is the question. So again, actually just to zoom out a little bit here, I'm Scott, should have started with that introduction, huh? But I'm a solutions engineer at Monte Carlo. I was the first solutions engineer / sales hire here. So I've been on board for about a year. Before that, I spent 4 years at a company called Segment. So a little bit further upstream in the stack on the data collection and routing side of things. And before that, I was at a company called Media Math, where I helped our customers with data activation. So activating their first and third party data for ad targeting. So worked in data my whole career. And then my fun fact is that I do have a really wonderful, cute puppy. He's a mini Australian Shepherd named Mosey. You can see him down there. And he lives with my girlfriend and I in Santa Monica. So back to the topic at hand. I'm sure you're all kind of generally familiar with what data mesh is and what the differences are between like a centralized data architecture and a data mesh type architecture. But just for a really quick refresher, the centralized data architecture is going to, that means that your data and all of the data infrastructure is going to be managed centrally by usually a central data engineering team. And this is a really great architecture for small teams, people who maybe don't have a ton of data or aren't yet at the point where they can actually use data to drive their critical business decisions. So how that actually manifests is you have a small number of data use cases. Maybe you probably power some like revenue reporting, maybe you do some lightweight product analytics, but at the end of the day, data isn't what's driving your companies. It's the ideas and execution of those ideas to get you to kind of that product market fit, regardless of what industry. Obviously, there's exceptions here. Some early stage companies are 100% kind of data driven because their product is data. But for the vast majority of companies, when you're still trying to figure out whether or not you have an idea or a product that you're going to be able to grow to hundreds of thousands or millions or billions of users and make a lot of money off it, the centralized kind of data lake setup is usually sufficient because it's the easiest. You don't have a lot of resources to build out a really complex ecosystem. You want to just get everything into a place where folks can query it, use a lightweight analytics tool to get those types of insights, et cetera, et cetera. And the other piece there is the assumption is early stages, you're not going to have too many domains. So maybe 1 or 2 products, and then you have some finance and maybe some operations data, but the breadth of your data is relatively narrow compared to more mature companies. On the kind of data mesh side of things, the more decentralized, we see kind of a turning point at a lot of the companies that we work with, where they're starting to use data for a lot more of their decisions. And the companies have a deliberate, kind of explicitly defined and shared goal to use data in decisions, use data in products, and use that data in more or less real time. So once a company gets to that point, and it varies, it could be 50 employees, it could be 100 employees, it could be 200 employees, depending on what industry, what type of product you're actually building. But ultimately, you'll hit that turning point where the central data team actually becomes the bottleneck. And you don't want to slow those product teams, those finance teams, those marketing teams down. You want to enable them to get insights on what they need when they need it, rather than having to file a ticket to spin up a new dashboard or to collect a new set of data. And when that teams start thinking this way, what typically happens is that centralized data team becomes more of a infrastructure delivery team. What they're delivering to the business is the data infrastructure. So that means how to ingest the data, how to process the data, and how to surface the data. And they own the infrastructure layer, but then they enable those tactical domain-oriented teams. Again, it could be a product team, could be a marketing team, it could be a finance team to actually kind of build their own data products, which is usually, again, when that turning point happens, it's usually still just dashboards at this point. But in some cases, it might actually be data products as well, where you're surfacing data up to external users, customers, partners, etc. So again, just to recap there, when the kind of number of data use cases and the number of people using data at your organization starts to explode, that's when you should start thinking about a decentralized data mesh type approach so that the central data team doesn't become a bottleneck and slow down other teams. That's really kind of the high level overview here. So, and kind of this is based on our learnings from, we've talked to thousands of data teams from all shapes and sizes of companies just over the past couple of years here at Monte Carlo. So it's not perfect. We don't think we have it fully right here, but this is what we see as kind of it working. But obviously you need to build a distributed data infrastructure or architecture. You need your data engineers. They're going to be the ones that are spinning up this architecture, making sure that it's available, it's performing as it's expected, making sure that the data is arriving into it as it's expected, things like that. And then you're going to also need what is some people call embedded analysts, analytics engineers, BI developers, but more technical analytics folks who are very kind of proficient in SQL. Can build last mile pipelines, can build out dashboards and reports, things like that. But they still need to have their hand in kind of writing some of these pipelines. It's not just going to be queries to power a dashboard. They're going to have to do some processing and aggregations themselves. So definitely need to lean a little bit more technical there than maybe your typical analyst. And then on the process side, I mean, this is the same exact type of process that you would go through in building any other product, okay? So you need to act as a kind of data product manager. So put on your product hat, go out, gather all the requirements, which means going and understanding the kind of domain specific needs for each domain. So talking to your marketing team, okay, what insights do you need that you aren't getting today? What's the best way to get them to you? How often do you need them? Do you want to have flexibility to build your own dashboard, or can we just email you a report every morning with those insights? So going out and learning all of those domain specific needs is critical to kind of the initial architecture that you're going to map out. Second piece is just have an understanding and start to think through like what's going to happen in the future. Because as you grow, you're going to need to think about interoperability, because your data science team might not be able to work out of the same data environment that your analytics team works out of. They might need something that's more real time. Data governance, you need to start thinking about how you're going to empower those end users to actually find what they need and know that it's right and know that they can rely on it. Shameless plug, that's where Monte Carlo and data observability comes in as well. And then the last piece on this is making sure that everybody at that uses data at the organization kind of knows how the data actually behaves. So that involves setting up things like SLOs and SLAs around the data, so that people aren't blindsided when a table that one person expected to get updated at 9 a.m. actually didn't get updated until 10 a.m. So the report you just ran was based on yesterday's data. Just making sure that everybody who is going to be working with the data has that visibility. And yeah, at the end of the day, you want to make sure that that team that builds out this architecture needs to make sure it's trustworthy and reliable. This data mesh falls apart immediately if folks don't trust the data. They just don't use it at the end of the day. Last slide for me, just to recap here, and some other kind of considerations here is, you got to think about how much, like the breadth of your data. Do you have a ton of data sources that you need to make these decisions? Where is that coming from? How is it getting into your data environment? Second is how many folks you actually have working on data across engineering, analytics, data product managers, if you have any, things like that, because they're going to all play obviously a critical role in this. The data domains, the kind of breadth of data domains is also critical here, as the number of data domains, thinking about both kind of product versus marketing versus operations. But then as you grow and you get product marketing and operations for each product domain, and you can kind of see all the permutations from there. So it grows pretty quickly once you kind of hit scale as a company. And then the kind of biggest question that I always ask customers or prospects that ask me this question is like, should we move to this data mesh thing? Is like, is data engineering slowing down your analytics org? If the answer is no, then probably not. If the answer is yes, then you should start thinking about it. But it's probably not investing in it. Like any product problem is probably not worth investing in until it becomes a big problem and people are really kind of hurting for data. And then the last piece, it's everybody's least favorite topic, but it's critical, especially useful to think through in the early stages of your data mesh journey, is how are you going to govern this thing? Because the longer you wait to answer that governance question, the harder it is to get a handle on everything and the more resources you're going to need to do so. So yeah, that's kind of the very quick overview there, and I'll hand it over to Barr now to talk through kind of how to think about getting value and measuring value for this. But yeah, everybody will have my information, so feel free to reach out if you have any questions or want to talk through this more. Take it away, Barr.
Thanks, Scott. Hi, everyone. If y'all have questions for Scott or any follow-ups, feel free to drop in the chat. We'll collect those and try to get to them throughout or after. Yeah, let's talk a little bit about how to measure data mesh ROI. I'll introduce some concepts here, and then Antonio will actually show us some real life examples, which I'm really excited about. And there's a quick question, will we get the presentation? And yes, we're happy to share the presentation after this. So just a brief intro about myself. I'm the CEO and co-founder of Monte Carlo. We're a data reliability platform. We work with tons of companies like Fox and Vimeo and PagerDuty and Affirm and Kolibri Games, helping them along their data mesh journey, delivering data that's reliable and trustworthy. Fun fact about me, I'm a big Bruce Willis fan. So if you have Bruce Willis questions, I can take those too. I'll keep this short. Okay, so I think maybe the first question that comes up is when folks try to implement data mesh is who actually should own this and how should we think about like who owns what part of it, right? It kind of seems like this big endeavor for people to go on kind of the data mesh journey, if you will. And so one of the sort of frameworks that we've found particularly helpful is a framework called RACI, which is actually we didn't invent this, obviously. It's a pretty sort of straightforward way to think about ownership. RACI stands for R is responsible, A is accountable, C is consulted, and I is informed. And basically the idea is for every different kind of part, let's say, for example, facilitating data accessibility or making it easy to interpret or access the data or ensure data compliance, there's a number of different people. First and foremost is the person who is accountable for it. So this person, their neck is on the line, if you will, when it comes to deliver on this item. And so they're kind of on the hook to making sure that it happens. Then there's the person that's under the R who's responsible. That's the person who's actually executing it, who's actually doing sort of the work of making the data available, whether that's like setting up the right reports or ingesting the right data or even identifying what data you'd want to work with. Then C stands for consulted, which is the people that have input into how you set this up. And then I, informed, is the people who need to be aware of what's going on because it might impact them, but don't necessarily have input. They might not. And so this is an example of a RACI that we put together with one of our customers. We highlighted data engineering here as an example, but as you can see, data engineering is responsible for a lot of different things in this organization, including making data accessible, maintaining high data quality, and delivering on data reliability, which is all of the R's, but are also consulted and informed in a lot of things. For example, they're not on the topic of data compliance, which is the fourth row. Data engineering is not accountable or responsible for that, but they are indeed need to be informed of that so that they can help the organization stay compliant and to drive the best practices around that. So what we found is this exercise is just helpful for folks, especially as they're trying to ask themselves, what does data engineering, what does data science, what does data analytics, what does the infrastructure team, who's doing what and in what function? And so actually starting out with this point can start actually help facilitate a discussion. It might be very different for different organizations, obviously. You might not be doing all of the things here on the left-hand side, and you might not have all the organizations on the right-hand side. But thinking through the accountable, responsible, consulted, and informed methodology can help you start having that discussion. So then some of the questions, sorry, and I see that there's some questions here that we can take a little bit later, but you know, on what makes a successful mesh, right? So Scott introduced earlier sort of the concept of what's a data mesh, and Antonio will give us like specific on this. But fundamentally, you know, when you sort of talk to Zhamak and read articles and read sort of about data mesh, there's fundamentally sort of 3 core ideas or 3 core principles that would make sort of, you know, an organization or some structure be considered sort of a successful data mesh. And the first is the idea of sort of these domain-oriented data owners and products, right? So not just a single centralized platform that sort of owns everything and ultimately becomes a bottleneck, to Scott's point, right? When there's just a long list of tickets that the centralized team never gets to, but rather there's a centralized teams and these domain-oriented products and owners who can actually move independently and move faster, which is very important. The second important pillar is self-serve functionality. It's kind of, I remember a customer tell me this, it's kind of funny to sort of expect people to own data and to own data products, but to not be able to answer fundamental questions about the product or about the data, like where did the data come from? Or when was it last refreshed? Or when should it get updated? Or can I even trust it? Right? It's sort of, we can't really expect teams and organizations to fully own something without having the ability to truly answer those questions. And so developing the ability to self-serve these organizations with those tools for governance and access and trust will enable these teams to actually operate in this decentralized fashion. So that's really important to think, okay, I have the centralized or kind of the infra group that's responsible for kind of the best practices and the standards across everywhere. But what do the decentralized, the domain-oriented owners actually need in order to operate, right? That's not straightforward, and you need to enable them with the right tools for that. And then finally, you know, the interoperability and standardization of communications. There's so many tools, or so many solutions, or so many different kind of things different ways that we can go about defining the data mesh and defining sort of the different ways in which we function. It's really important that we align on standards for metrics and SLAs, and we'll talk a little bit about that, and allow interoperability between these different systems so that we can actually think about things end to end, right? So the age of data being in silos and for us thinking about very point solutions is no longer sufficient, right? And we really have to think about kind of the concept of end to end to really enable us to deliver on this. And then finally, you know, the bottom line question is like, if the mesh is successful or not, is our organization actually better, right? Have we actually accomplished something? And then it begs the question of what are we trying to accomplish? If we can move on to the next slide. You know, I think at the outset of any sort of journey or of you know, sort of I mean, I know the word transformational change is a cliche, but you know, as Zhamak points out, this is quite a transformational experience for an organization, and I think you'll see through Antonio's story that they've gone through multiple of those, and each one takes a lot, right? And so I think at the onset, trying to define what are we trying to improve and being really, really deliberate on that is very important. And you know, the real answer is that this would vary based on the maturity of your organization, the stage of where you're at, and what you're trying to accomplish as a company. We sort of see this kind of like follow the hierarchy of needs. You know, at the very beginning of a company organization, you just need to like be able to report on a few basic things that the company needs, right? So you just need the data and you just need it available. And then later on, you need to make sure that more people can have access to that. And then later on, it becomes even more complicated. And then you start thinking through, wait, now we actually need to be able to trust the data and everyone needs to have access to it. And we need to be able to discover it. becomes a lot more complicated. But depends on where your journey is, you might have different outcomes that you're trying to solve for. One of the more common ones that we see is obviously, there's like number of data products and, sort of the adoption of the data mesh, if you will. Time to insights is one that I think that's very interesting. And actually an additional one that Antonio will talk about a little bit later is the percentage of decisions that are made based on data. And, I think that's a very powerful metric to look at. How many of the decisions as an organization that we made are actually gut-based, and how many do in fact rely on data and analysis that we do. And what is best in class? What do we expect? Do we expect 50% of our decisions to be made based on data? More like 90%. On time to insights in particular, some organizations measure things like, what's the time that passed from when they first query the table, when they actually sort of used it and sort of did a transformation, or actually like created a report based on it. So organizations are becoming more adept at actually measuring some of these things and making sure that they improve on them. And if you sort of deliver successfully on your data mesh strategy, that means that you've enabled your team to use data more, to access it more, and ultimately to become more data driven. There's some great question here. In the RACI matrix, shouldn't data governance be responsible for data quality? That's a great question. Who owns data quality? So I'll start by asking. I'll start by saying it's quite a loaded question, right? Because what does responsible actually mean? And does that actually mean that responsible in the RACI sense, or actually accountable for it? Oftentimes we see data governance accountable for it, but actually data engineering responsible, maybe meaning the data engineering actually sort of defining the SLAs, defining what does reliable and trusted data actually means. And then the data analyst often also has a role in that too. So it really depends on the definition of what your data governance team actually does. It does vary very, very much between organizations. So I don't think there's a right answer in particular. It really, really depends on kind of what different functions you have and what you're trying to solve. So the sort of example that I showed in the RACI matrix is really just an example. You can definitely change it based on sort of your needs. The goal is really just to facilitate a discussion on who owns what. In some organizations, the data governance indeed is responsible. The data governance team indeed is responsible for that. And in that cases, they would actually be acting for it. But that's less of a common common structure that we see. We typically see other teams being responsible for it. Yeah, looks like Antonio, you're ready.
I think so.
So I will hand over to you, and we will take the rest of the questions offline, and we'll get back to everyone.
Awesome, thanks a lot. So I think now we're ready. We can start the presentation. So just to introduce a bit myself. So my name is Antonio. I'm the head of data engineering at Kolibri Games. So I've been working at Kolibri Games in data engineering since 2018. It's been 3 years, so I've been through quite some of the transformations that we have been through. I'm originally an electronics engineer, so it was my master's. So I think it's another presentation just to explain how I ended up working with data. Currently based in Berlin, that's where we are also have our office at Kolibri Games. And I'm a bit of a music nerd, so I do play a lot of different types of instruments. And in 2021, I decided to pick the saxophone. So it's been quite exciting also for myself also. So jumping right into my presentation. So what I will start by is just giving you a bit of context about Kolibri Games as a company. The idea is to get like an idea about what we are doing, what is our product, and how did we get into the place that we are at the moment. And then I will align through the years some of our company goals to our data, and basically I'll be touching in topics like our data architecture, our data organization now, and how we structure our teams. And also I'll be talking about what data mesh meant to us and how it impacted all of our data transformations, basically. So I'll start from the beginning. So the company was founded in 2016. it was basically built from our founders' student apartments, and basically they decided to build a game. They built the game called Idle Miner Tycoon. It ended up being quite successful, and to grow up, in 2017, the company decided to move to Berlin. So the idea was to grow, attract new people, being in an environment more international and close to the other partners that we were working with. In 2018, we achieved the amazing achievement of getting 50 million downloads. That's also when I joined the company. I was still able to join the celebration. It was amazing. And if that was not enough, in 2019, we reached the double of amount of downloads. We also increased the size of the company. We were back then, we reached the 100 employee number. And in 2020, we were really happy to join Ubisoft. And probably you already know, but Ubisoft's a big company with decades of experience on releasing successful games, and it meant a lot for a successful company like us to join together this family. By the end of 2020 and 2021, we increased even more the portfolio of games that we're working with. So we went from 2 games to 7 games at the moment, and more will come. We also opened a studio in Bucharest that is helping us develop also new games and new concepts. So at the moment, like most of our data is being generated by Idle Miner Tycoon. It was the first game that we developed. That is the one that at the moment generated more number of downloads and more number of players. It's a mining game where you ended up managing a lot of different mines and being able to generate more and more income to get more and more mines. It's a game that works pretty much as a service. So it's not something that was released 4 years ago and stayed like that. So the type of games that we're releasing are actually evolving through time. They're pretty much different from what they were maybe 6 months or 3 months ago. And every week they get a new release. So it's very fast paced, and we work very fast to get new things going on almost every week. So if you're interested in that part, we have a lot of about it on our blog post. We also have a podcast where we talk about like how we release games and how we set up our basically our live operations around that. To give you a bit more context about what it means to data. So at the moment, Idle Miner Tycoon and all the other games are generating around 100 million of events per day. We're talking about 40 different event types, some of them with dozens of different triggers. And considering all of the events and all the data that we're modeling, we are now getting around 50 terabytes of data into our data warehouse. So basically, to power such growth, data played a very critical role there. So I want to show you how that works, and I will be aligning some of our company goals to how our teams were built, how we evolved our tech stack, and basically also sharing with you some of the challenges that we had. So starting from 2016, our first needs from data, we basically just needed to establish the basic to understand how our game was working and if we're making any money out of it. So for that, we needed to track how we were making money. Basically, the games have to generate money through the offers that you can get to get more boosts inside the game, but also through rewarded ads that could also give you boosts and help you improve and evolve in the game. I also wanted to know more about some game-specific KPIs to understand how the game was performing. So things like retention or retention of the games, and also understand about like crashes and bugs on the game. So for that, and the first approach was actually using only third-party tools for that. So we, as a very lean company, didn't see the need of setting up like our own infrastructure to have that. And basically, we're using Facebook analytics to get some of our high-level KPIs, Firebase to tell us like about like crashes on the games and so on, game analytics for more in-game specific KPIs, and from our ad partners, we're getting our ad revenue. This approach, though, starting to be, or it was far from perfect, especially all of our analytics was scattered a lot, around a lot of different tools. There was no transparency about how the KPIs were being calculated, and most of them differ from tool to tool. The numbers that were being reported were quite different. Also, and although we didn't have like a data platform or a data analytics team to maintain, there was still a lot of tech problems that were coming up from integrating some of those tools with our game itself. And in the end, the tools itself didn't give you a lot of flexibility and the capability of digging deeper into some of the things that you might want to know about the game. Even though these were the challenges back then, those were not the first things that we aim to tackle. So we're very lucky that we got a lot of players in the game coming organically, but we wanted to get more and more. So for that, we wanted to ramp up our marketing and user acquisition operations. And it was very important for us that those operations were scalable and that we're not burning money just for the sake of. So we set up a lot of performance marketing capabilities on our data capabilities. So basically, we wanted to be able to measure ROAS, which basically means return on every ad that we spend. We also build an LTV, which means the user lifetime value predictions to understand or about like if our players were actually like being our game is being rentable or not. And we also built a bidding algorithm that will pick up the performance of our marketing operations and bet more on campaigns that were actually performance and less on campaigns that were not performance. So the data team back then was a marketing manager that was basically running all of these operations. And in 2017, what we added was just another tool, an MMP tool called Appslier. Maybe some of you know about it, which basically give us the information about from which user acquisition campaigns we're getting players and how much cost we're getting. We're getting those players together with other sources. We were able to get how much revenue those players were generating, and we built those bid management operations around our scripts that we were running locally, basically. So I think that accumulating with the challenges of the last year, all the fact that we are running these operations almost locally, you can imagine that it brings a lot of problems. So there was no transparency around what was happening or not. It was quite error prone, so no data validations, no checks. So we're basically blindfolded around those operations. We introduced a new tool, so data was even more scattered around those basically around those other tools, and we didn't have any version control or engineering best practices around the code that we are running for updating our PIDs. And so that's why in 2018, we decided to centralize our data. So we wanted to gather all of our information on a single place and achieve what we call like the brain of Kolibri, getting more transparency about how performance in marketing was being done, and also being able to deep dive into our data. So for that, we decided that we didn't want to rely more on those third-party tools and wanted to build a data platform analytics, and we decided to invest on our own solution, which means that we'll start to collect our raw data, we start building up a central data warehouse, and start setting up our own dashboards. But that's also more or less through this time that I jumped in together with another data engineer that worked together with the marketing team to get this platform running. And I'll show you what was our first iteration of a data platform. We're basically using Azure for all of our services. So we built from our game some event telemetry that generated data points for some specific events or from specific actions on a game. We used event hubs from Azure to get those data. It works like as a message queue, and then Stream Analytics, also service from Azure, to process and transform that data and store it in our data lake. We also had a couple of other API integrations. So we set up some batch jobs that were using Azure functions to integrate data also in the data lake. We use the service from also Azure called Data Lake Analytics that basically it was a non-demand data processing engine that would basically transform all the data that we're getting and eventually integrating it in a SQL database that was working as a data warehouse. And initially, we're using Power BI for all visualization and dashboarding. And we ended up removing that piece and introducing Looker. Looker also works as a visualization tool, but what it gave us back then was another layer of data manipulation. So we could use non-SQL code to work around some of the transformations and some of the data cleaning and preparation for visualization of the data that was on our SQL database, and some also out of the box cool features that help us to collaborate. So for example, there was like we could set up like a version controlling around the code that we're building in Looker, and also a small development process that allow us to have a development environment for some of those transformations. So basically, we set up like this end-to-end platform, but soon we start seeing that we're starting to getting a lot of challenges. So first, our SQL database was becoming a limitation. We were writing, or the jobs that were integrating the data were writing the data at the same time that our dashboards were running, or that analysts was doing an ad hoc query, and basically the whole service starting to become very unpredictable and very slow also during those times. Also, we start seeing that some of our jobs were failing a lot, in the sense that any mistake that was done will mean a lot of costs for mitigation. We also had limited alerting on monitoring, which didn't allow us to answer at time to some of the things that were happening. And also like for the systems that we were running. So we had some difficulties around keeping the system alive, And again, at the minimal error, it will take us a lot of time to recover from that. So in 2019, we said that we wanted to get data oriented and start addressing some of the problems that we had. So continuing getting more, we had a lot of raw data already on our data lake and our data warehouse, and we wanted to get more insights from player behaviors from that. We also wanted to start building experiments backed by data and maturing the tech stack to address the stability and performance issues from before. So for that, we built dashboards for monetization. We wanted to understand how much we earn with each offer and or shop or ads, and also building more dashboarding around how players interact with the game. So understanding like when players were dropping off, what were the features that they interacted more, and so on. Started also by running A/B testing on using our platform and focusing on increasing the performance of our warehouse and maintainability of our data pipelines. So for that, and to tackle the first three objectives, we hired a head of game data that will help us to push on that direction, and also two BI developers that will help us to build the dashboarding and all the data modeling for those node use cases. We keep the data engineering team to build everything that was more related to infrastructure and tackle the technical challenges that I already mentioned. So from now on, like there will always be in the teams of data engineers and BI developers, and I've seen like some discussions around what those titles mean. So just to clarify, a data engineer at Kolibri Games is someone that works more close with infrastructure and maintaining systems and integrating new tools and maintaining like our streaming use cases and building frameworks for BI developers to work with data integration, data modeling, and data visualization. In terms of data stack, the main change was replacing some of the Azure services with Databricks and Spark. The main reason was that Databricks is a platform where all the BI developers, data engineers, and head of game data could work together. And also, it gave us like some flexibility and easiness about using Spark. So we moved our streaming integration from the Azure service to here, where we could be more easily customize what we wanted to do. Through this year, and our first approach was using our data lake as our data warehouse by using Spark with it. It didn't work so well, and the main reasons for it was that Spark requires more specialized skills to work with data, and basically the people that were working on our data platform prefer working with tools like Python and SQL. And in the end, it needed more support from data engineering regarding like file optimization and partitioning and those kind of things. And we never find a way to get the performance that we were expecting when working through Looker with Spark. And that's why we ended up replacing our SQL database with Snowflake. So Snowflake started working as the main computation engine for all of our analytics. We also at this time replaced the Data Factory for orchestration with Databricks, as it has like scheduling inbuilt in their services. So continuing with the trend before, we're continue to generate even more data, but we knew that we could even utilize it more and build more use cases around it. The A/B tests that we run were very hard to set up, and there was missing transparency around the whole process. So no dashboarding or way of presenting those. And even though we're setting up like even more dashboarding and so on, and that our product managers were looking into our data, most of the decisions were still made out of the intuition and community feedback. So since the beginning of the company, we take the feedback from our players into account. But what we found out is that it's a minority around 100 million players that we're actually having. So it's usually called like the loud minority. And what we did in 2020 was getting data-driven and starting to approach products more to data and building a product that was actually driven by that data. I think this year also is starting to get more interesting in the sense that data mesh discussions starting to appear inside a team. I think like from the goals that we get that we define, we aim them to be more measurables that we can measure through what we're doing. So these SLAs are basically we define that we wanted 90% of all of our decisions on our main game, Idle Miner Tycoon, be backed by data. That the time to insight for all data related questions needed to be smaller than 1 hour for 90% of all questions, and that 90% of all changes needed to be validated by analytics. So this time, product manager was more involved on this whole process, and we were able to keep track of all of these metrics by using Jira tickets or manually tracking those answers, which in the end, I think it was a big motivation to help to create a data culture around how we were working in our games. So we got four main initiatives around becoming more data-driven. So we wanted to improve on our A/B testing process and by making more informed decisions about changes that we wanted to make in the game. We wanted to make a game that was more personalized for each of the player. We start also by introducing some data science, more specifically machine learning capabilities on our data platform, and also getting more and more insights and building a culture of people requesting more about data and building more capabilities around getting answers from our data. And more specifically for that, we got quite inspired by the data mesh conversations and what we're reading about data mesh. So more specifically, in 2020, we aim to have a domain agnostic data platform infrastructure as a service and an end-to-end domain data ownership. So I'll get more deep into that while talking now about the team and the tech stack that we picked. And so basically, with what the changes to or the new introductions to the team was getting a product data analyst team. So this product data analyst team was not part of the central data team, but was working much closer with our product managers so that they could actually better understand and better align what were the priorities and what the product actually needed. And also for the data science capabilities that we wanted to introduce, we also got like 2 data scientists that work specifically on our machine learning algorithms and also on our A/B test data pipeline. So for tech architecture, for our tech architecture, like the main changes was basically we added data warehouse architecture into our Snowflake, which help us to define better where we're applying the business logic. So we moved from doing ETL to doing ELT. So all of our data was arriving in Snowflake basically as it was, and all of the cleaning, the filtering, transformation was being done there. We combined that with dbt so that we could use this tool as a way of collaborating between everyone that was working on the data platform, so analysts and the data platform people, which help a lot to increase the visibility and the transparency about what processes were running and so on. Also, by doing this, we start abstracting some of our data pipelines, mainly the ones that were generating more data, so that we didn't need any specific developments or transformations if we're adding new data points or new data events. Data engineering focused on building this framework, which means that at the end, product analysts could basically own the design and the definition of new data events together with the game development team. And if they follow defined guidelines and rule, they could then get that data into the data warehouse and model the data for creating new insights without the interference of a data engineer. So we also introduced Airflow as our main orchestration for our data integrations, all of our dbt models, and the data validations that we were running. What happened at this point is that we got much more data and much more new use cases around data and a lot of new models, but it was starting to become difficult to monitor all of these and to make sure that things were correct. So we're starting having big problems around data, which made people stop trusting so much about like what we were delivering as analytics. Also, we got a lot of new people working on our platform. We're starting to see a lot of software stability around the jobs and the models that we're running. And we also missed how could we actually scale the game personalization for our players. So for 2021, what we did was focusing mainly on the first two problems on the data platform team by what we say was what we call like strengthening the foundations. So again, we're getting a lot of new data, use cases. Also with the new games, start generating a lot of new data, and we wanted to focus on speed of development, reliability, and maintainability. So focus on increasing the speed of development and mitigation of incidents, also decrease the number of incidents that we are having, and decrease the player personalization with further advanced analytics. So for that, we wanted to increase our testing capabilities, build a common release and development process around all of our teams that were working on the data platform, getting more monitoring and alerting tools, and also focused on advanced analytics. What we see and what the data mesh inspired us here, or what we wanted on what we take from data mesh is basically increasing the collaboration between the data platform teams and extend the capabilities around data monitoring and observability and implementing engineering best practices, and also start building domain cross-functional teams. So at the moment, this is still a work in progress, but what we see is extending our domains teams that before were composed mainly by analysts, by introducing the role of a PM, a project manager that will help to define the work for that team, and also introducing the BI developers into those domain teams. So the idea is that a BI developer working mainly on integrating new data sources and working on maintaining the ones that are existent. So having it closer to product to better define, again, like the priorities and the needs for that domain, and the same for marketing. At the same time, we'll keep a central data platform team, so data engineering focusing on building the solutions, frameworks, and maintaining the infrastructure, and also everything that is related to advanced analytics will still be part of the core data platform team. So in terms of tech stack, what basically happened is that we start centralizing all of our development and release processes. So we combine, or basically, although we are like a data platform team and marketing team and product team, different teams that have their own agenda and their own objectives, we all work on the same systems. So we all follow the same merge request process and release into production process. We all also take advantage of each other developments and ideas, basically, and share a lot about like how we ended up doing new things. So also increasing the knowledge that is shared between teams, so that no one has to solve the same problem twice. And also the introduction of Monte Carlo as our data observability tool. So we got in 2020, or by the end of 2020, we got into our own custom solution for data monitoring. What we found out is that at a certain point, we might need a full-time person actually working on a framework if we really wanted to extend it to a lot of our different use cases and being able to monitor all of our data assets. So Monte Carlo ended up helping us solving this issue. So at the moment, we are able to monitor the quality of our data, all of our data in our data warehouse, and also give us extra capabilities about understanding the lineage of our data, and which has been proved very useful when you wanted to troubleshoot something, or you want to better understand for what that data set is actually being used. So that's the current state of our data platform. And as I said, it's still 2021, still in the middle, so it's still a work in progress. And pretty sure that especially we're a company that we're very fast, which means that we also iterate a lot about what we usually do. So can't promise that we ended up getting to the point where I was showing. So what I wanted then to share with you is a couple of learnings that we had and that we collected through these years. So I think it's useful if you're starting introducing data into your own company, or if you're going through a transformation of your data platform and so on. I think like the main key learnings that we obtain is that it pays off like building your own data stack, as it gives you basically like all of these capabilities and allows you to be data driven on your product development, on your working on your team. Also, we've been through a lot of iterations over our data platform, so kind of had to choose and being able to understand when it's the right time to change technology for which right amount of data or for which process that you're running. It's very important to have a higher degree of data quality and data observability if you want to establish trust in your data. It's important that you are able to understand when there's a problem and that you're able to indicate that easily. So getting the basics right, it's also quite important before advancing to more advanced data applications. In our case, we would have hired analysts earlier to make more use of the data, and establishing a data culture is also quite important, and sometimes even better than building the right tech stack. So I think that's it from my hand. So thanks a lot for your time. We are sorry.
I was going to say, I mean, we've got some questions in the Q&A. If we'd love to spend some time with.
Yeah, sure.
I want you to be able to wrap up here. And yes, you are hiring people, and it sounds like it's a great org. So as well, if you've got that link actually handy, I'll put it in the notes for when we post to YouTube. But if you can throw that as well in the chat, just so if anybody's interested. But yeah, so we've got some questions here in the Q&A. Some of that stuff. Yes. Oh, and you're still sharing your screen. I don't know if you want to. Okay, that's great. So we've got some different questions here. I think maybe if I could start with a question as well. So a lot of this was evolution. You talked a little bit about what was not being afraid to make changes. I think within data mesh as well, there's questions about how do you deal with that kind of culture change around being able to break things, right? And that you do that with intentionality, and that you're not doing it because you're moving too fast or you're being careless, but where you say, hey, we're going to make a breaking change. So this thing that you relied on is going away. Like, how have you dealt with communicating that internally? You talked about you've got a data-driven organization, data-driven culture. How do you really deal with that?
Yeah, I think that's a good question. So what helps is that our company culture is a lot around go fast, fail fast, and learn around it. So it was kind of natural that we also applied it to our data teams and how we work. What we found out is that on our case, it means that, like, for example, sometimes maybe our data warehouse will be down because we deployed maybe something new, or we make a change and maybe our data model was not ready, or a report was not ready on that morning, or something like that. And that actually damages the trust on the people that are looking into the data. What I think it helps a lot is transparency about those kind of things. So actively communicating when anything, when you know that anything is wrong, so that you are informed about what is going on is not, or what you're seeing is not expected. So we kind of build internally an open communication to everyone in the company about any data issues that we are seeing. And what was really important was building these data observability capabilities so that we could understand earlier than you that are looking at the dashboard at 9 a.m. that, okay, maybe our revenue is not completely integrated, or maybe that specific data model was not calculated yet for yesterday or something like that.
And, there's one here, I think, that's a good question around that. Talked a little bit about what you did with your team evolution and stuff, but like product manager acting as a data product owner, like how, you know, that responsibility split up, and there is a general question around data mesh where people kind of make the assumption, and I was really glad that you showed the evolution of your team stuff. I don't know if you want to share those any of those specific slides, but like of additional resourcing, right? That there is an investment in doing this right. But like, you know, how are you feeling around splitting up that responsibility? Can you have somebody who's already acting as something else act as the data product owner, or, you know, how have you kind of split up those responsibilities, and where maybe have you made some mistakes when you were kind of going through that? You talked a little bit about that, but love to hear more.
So I think that at the moment, like especially for what we want to do this year, we are still not there. So I think it's a matter of trying out and understanding how actually that could work. So I mentioned there a product manager who probably could also wear the product owner hat. Also, I think in the end, what is happening is that the managers that are working on the game are mostly wearing that product owner hat. So a manager becomes a product owner for our data team. We introduced the product manager, at least we thought about it, because there's someone that we feel that needs to manage like the data team and the work that the data team is doing, which is also a hat. So an analyst could also take that as a responsibility in the end.
And I just shared an article that someone at Snap Commerce, which I think is part of Snap Travel, shared about like how you should structure your data team. And I think it's from last year, but it's a really useful resource, and they go into super granular detail about how they built and changed their data team as they built out their tech stack and moved towards a domain-driven design like the data mesh.
And could you actually copy that again and make sure it goes to all panelists and attendees?
Yes.
So,
yes. Oh, sorry. Oh, sorry. Here we go.
No worries. And I'll have the link as well for recordings that we can put that into the thing. So yeah, Antonio, I don't know if you want to just go through any of the questions. Some of them are a little bit around some of Barr's presentation around the matrix and things like that. But, you know, like schema changes from operational store, you know, how do you deal with that stuff that's kind of upstream that might be a breaking change downstream? You talked a little bit about that, but like, you know, what's the communication path, and how do you do that ahead of time versus after time? And, you know, when data products break, right? Like things break upstream or changes happen and maybe it wasn't always communicated. So maybe how is it supposed to work, and then how does it work?
Yeah, actually that was a problem that we're facing. I think like with the architecture that we had back in 2019. So anytime that there was a change, we needed to know beforehand, and we needed to prepare our data structure before those changes were starting to become to all in. And what we did by abstracting our data pipelines was also applying it at the schema level. So we take advantage of just integrating as a plain string, like our events event data sets, with like talking about a JSON, and then in Snowflake take advantage of a variance data type to kind of store unstructured data, and at a next layer we would apply the schema. So we kind of like integrate everything into data warehouse, and then on a different process we will apply the schema. So anything that will change wouldn't break any of the data pipelines, and even if we knew it a bit later than what was developed, like we could always go back a couple of days and just reprocess that data. Sometimes because the game release, usually we do like a phase rollout. So maybe like in the beginning, we're talking about like 5% of the players get a new version. So depending on what data we were collecting, maybe it was not so significant not having that data collected. Yeah, I think we even have situations where we start collecting data points and it took us a couple of months until we integrate them because it was just not the urgent need. At the moment, this is actually the only process that the data engineering or the central data platform team are actually working on, but it's usually pretty straightforward. And it's one of those things that eventually an analyst could actually pick it up. Yeah.
And are most of your data products, is the data output port, is it mostly SQL, or is it, like, or is there not like a very specific one that you use? Is it kind of unique to each one, or do you have?
Can you repeat, sorry?
The data output port, like when people actually go to consume the data product, like is it via SQL or is it via an API, or what's the typical?
Yeah, typical it's via SQL. Yeah.
Okay. Yeah.
So yeah.
And there were a couple of questions that were early on that were for Barr's specific thing of the thing, but a general question that we see a lot is this question from Raghu about how do you actually identify domains, and how do you do that kind of bounded context? What makes a good domain? I mean, there's the concepts from domain-driven design, but it also becomes different when you start to talk about with data, because there's consumer-aligned, producer-aligned, domains, all that fun stuff. So like, how did you initially approach it, and then how do you think about where those bounds are around a domain?
That's a pretty good question, and I think it's not easy. So how we define it is basically when we assign an analyst team to a team, basically all of the requirements and needs of that team data related means that those things fall into that domain. What happens is that there's cross functionality around a couple of our data models or data products that we developed. Our approach there was actually on our data warehouse, and we used DBT for that, was defining main owners for our data models. They kind of like tag them, the models with this is like a product team model, or this is a data platform team model. And the rules that we define is that the team that owns it is not the main, is probably the main responsible for developing there, but not exclusively. So we kind of allow for teams to develop on in each other's, because sometimes it happens like your domains are not strictly defined. The rule that we define there is that if you're working on a model that it's not part of your team, you inform the other team that you will be working on that, especially not just after you develop or made a change, but also discuss design and architecture of that specific data model, for example, because we do have some documentation around that, but it's far from perfect, I would say. So it's kind of difficult to jump into something that we never worked with, and we solved it with using this mechanism, and it's been kind of helpful because I could be making a change on a product model. I will sync with the person to understand actually you designed it and what was the intent for it.
Yeah, there was an interesting blog post recently by Adaventa where they talked about every single data product they have has two different notebooks with it, and one is kind of a sample beginner notebook, so that people that are just trying to figure out what's in it, they can do that. And then there's an advanced notebook for the data scientist and things like that. I don't think it didn't sound like you've got a team of 30 data scientists, so there's not as much of a problem set for you. But like those kind of things of and it doesn't sound like you've got a team of, again, like 100 data analysts or anything where you can kind of have those one-on-one interactions, but still like that documentation and that, like, can somebody even just poke around at it and figure out what this is important and interesting. So I think we want to be cognizant of your time. I want to make sure that you can get to dinner and stuff. So Maybe we'll take one more. Is that all right with you? Or
Yeah, fine. We can keep going if you want.
okay, so there's a question here about data culture and like, how can you define that? Like you talked about not having, really a great data culture and then moving towards it. Like what can people learn from that, or what's the way that you define it? And yes, everything's going to be a little squishy around that definition, but like, how do you think about data culture and how do you think about moving your team towards that?
I think data culture, it's a lot about your teams inside your company using data for their day-to-day operations and their day-to-day decisions, right? So, on our case, what happened is that a lot of the decisions were based on gut feeling, on what you think would be good or not. And we wanted to change that. So I think it was a really good work what we did in 2020 when we tried to measure how we were actually using data for our product development. So getting those KPIs around how many questions were we doing that were backed by data, or how many decisions we were making that were backed by data. So those kind of things, measuring those kind of things really helped like people to think more about it and to push more for it. So I think that more than the results that we obtain by that and more of what we measure, the exercise by itself proved to be really fruitful in terms of getting more people to think about data.
Okay, that's awesome. And then we do have one. You said that you're okay to go one more over. We have one last one that's for you. The other questions I think were for specifically Barr and things like that. So we'll take those, and the Monte Carlo team can answer that offline about data products, and is that really bad for a small company? No, but you don't need to build a full self-service platform, those kind of things. But so in a decentralized ownership model where each team owns their own data product, assuming that kind of centralized data governance model, do other teams have access to PII data cross context, or how do you deal with that PII? How do you deal with GDPR so that you're not necessarily exposing it to everybody, but do you do RBAC, or do you do like, how do you think about that as well, as to what data you might need to keep on the inside and what data you want to share on the outside, but that's sensitive?
Yeah, so we by principle don't collect much sensitive data about our players, so it's very much not personalized. I think like we can identify them and we have then processes like when we get like requests about like getting data or deleting data and so on, but most of the data is not personalized. So I could track a player inside the game, but I don't know nothing about like outside of that world. So I think this was, and especially when we start collecting this data back in 2018, that was like the big topic of the on the industry, and everyone was working with data. So I think we already back into the decision of avoiding collecting data that we really don't need. Yeah.
That's good that you have the ethics to not just say we can collect the data, so let's collect the data.
Yeah.
That's always been a little bit of a fun thing. So, well, again, thank you so much for your time. I think we're good to wrap it up here. But do you have anything else that you want to say on the way out? You said you're in the Slack, so if people want to contact you, I'll post the link around the career site as well, and the two articles that got posted or that we talked about as well in this for people who are watching the recording. But thank you so much for your time. Do you have anything you want to say? Molly, do you want to say anything on behalf of Monte Carlo? Or
just want to thank Antonio for his time. His team is working on some really awesome stuff in their hiring. So if anyone's looking for data engine and your next data engineering adventure, they are working on building, I guess 3.0 of your data mesh.
Yeah,
at this
yeah,
point.
we hope so.
Yeah, and then if anyone has questions about observability, feel free to ping me. I'm in the Slack. And then for the other questions that we didn't get to, I took screenshots of them. We can either do it, live, or we can just, I can ask Barr and then share them in the Slack, whatever works best. I don't know, Scott, if you have a preference on that.
I don't, I mean, we
Okay.
might start up something that's a live Q&A kind of thing where people can just ask questions and, somebody is in there, or we can do on Reddit or RAMA or whatever, but we'll figure it out. I think we only had a couple, so I think we can just post those in the Slack, but going forward, we're open to lots of different things that people want them. But again, Antonio, this was super awesome. I'm excited as to how far you've come, and I'm excited to see where you go from here. And thank you everybody for joining, and look for more content. We're as of right now, we have a weekly meetup almost fully confirmed through the end of August, and I've got pretty much the people lined up for September as well. So there's a lot of people doing data mesh, and they want to be talking about it. So it's getting pretty exciting in this space. So again, thank you so much, Antonio, Molly, Monte Carlo.
Thanks
a lot.
everyone.
Thanks.
Have a great day.
Bye.